Hey guys, so in this video we're going to be going over the exponential function. We're going to talk about its graph and also the rules of exponents. So let's get started. So here we have that the exponential function is written in the form of, so very important, the exponential function is written in the form of b to the x. So b to the x. So let's talk about what is b and what is x, right? So the base of the exponential function, which in this case is the b, is always a constant or a variable. So it is always going to be a constant, all right? And the exponent is always going to be a variable. A common example is going to be 2 to the x, right? Which 2 to the x is our classic exponential function example that we usually talk about, and the straight opposite of that, right, is going to be x squared. So let's discuss 2 to the x and x squared, right? So in 2 to the x, 2 is the base and it is a constant, and the exponent is x and it is a variable. Now when we talk about x squared, the base is a variable x and the exponent is a constant 2. So it's exactly the opposite, right? So let's make sure that when we think about an exponential function, the base is always the base is always a constant and the exponent is always a variable. So also the value of b, which is your constant, is going to affect the shape of the graph, right? So let's talk exactly how. So let's say we have b, which is a number greater than 1, or just any number, right? So in this case we can talk about 2 to the x, right, as our exponential function example that we're going to have. This is going to give us an exponential growth, and what that means is that our function is going to grow as it goes to the right. So as we go to the right, our function is going to grow exponentially. So we're going to draw in like a reference point for us in exponential functions. So we plug in 0 and 2 to the x. Something that we should also go over: 2 to the 0, or 2 to, or any constant to the 0, right? Anything to the 0 power is always going to be 1. So anything to the 0 power is always 1, which is always a mistake that people think that 2 to the 0 is 0, but it's not. It is just 1. So we're going to draw that point right here at 0, 1. We have that coordinate, which is going to be our common reference point when we have exponential functions. So just plug in 0, see where it lands. It's going to be your center, and then you're going to grow exponentially. They can also grow different ways depending on the constant. So as long as it's growing, doesn't matter if it goes through that point or it can grow slower. Whatever it is growing and it's considered an exponential growth. Now, let's refer to the opposite case, right? The opposite case will be when we have, for example, a number between 0 and 1, which is another fancy way of just saying a fraction, right? So let's say we have a fraction being our constant to the x. So the opposite of this is going to be 1 over 2, right? It's the fraction version of 2 to the x, just a reciprocal, which is 1 over 2 to the x. So in this case, we're going to have, instead of a growth, we're going to have a decay, right? But let's draw a reference point first, right? So we're gonna have down here 1/2 to the 0. Anything to the 0 power is still 1, so 0, 1 is still a reference point. But now we're going to draw a decay, which means that as you go to the right, you're going to decrease. An example of a decay is your bank account when you go shopping. If you go really hard at it, it's going to decay real fast. So that is what we have in exponential decay. They also talk about it for like testing and all the boring science stuff, like decays when like your bones and things, whatever, all that boring stuff. So now that we've talked about how the graphs of these things look like, as long as it's decreasing, we can also draw an example where it's decreasing like this, or it's decreasing like this. As long as if you carry your pencil from left to right, that it decreases, it is a decay. If you grab your pencil from left to right and it increases, then it is a growth. Pretty good way. If you have a number, it's a growth. If you have a fraction raised to a power, it's a decay. So Now let's get to the good part of the exponential functions, which in my opinion is the rules to exponents. Because here in calculus, you don't know how many times you're going to be seeing the rules of exponents. They're like just hidden in there. Whenever you guys learn anything from now on, it's almost always going to have exponents. And you don't want to be struggling in the little parts that don't even let you learn the bigger picture of calculus. So let's get through those rules of exponents real quick, and then we'll do some practice problems, and you guys will be beast on this, and we'll get done with it. But let's start off with the rules of exponents, right? So there's 4 basic rules that I like to say about these exponents, right? First is when you have 2 things multiplying, right? So by 2 things, I mean an x raised to a constant and another x raised to a constant. And that just means not just x, any variable, right? So an example is going to be like x to the 2 times x to the 3, okay? So when I have x to the 2 times x to the 3, my bases are the same, right? My base is just x, or whatever x is. And then my exponent in the first one is 2. My exponent in the second one is 3. The x's are multiplying. So I'm going to write 1x, and I'm just going to add the exponent. That's exactly what I have here. If I have a and b multiplying, the a and b are going to add. So if I add 2 and 3, I have x to the 5, right? Another way of seeing this, right, is like that if I have x squared, it is having x times x. And that if I have x cubed, it's like having x times x times x. So here I have 3 x's from the x cubed. Here I have 2 x's from the x squared. So I really just have 5 x's in total. So that is where the rule comes from, right? Because if you have 2 x's and then 3 more x's, you really have x to the 5. So now let's go into what happens when you divide, right? So let's say we have x squared divided by x to the 3, right? So I'm gonna have to subtract because I have the same base and they're dividing. So when I'm dividing, I'm subtracting according to my rule, and that is going to be 2 minus 3, which is -1. So don't freak out yet because we have a negative number, but negative exponents are a big no-no. Teachers just don't like them. They just don't look simplified. Math people just get angry, like, we have a negative exponent. No. So this just cannot happen. So what we're going to do is we're going to just leave it there until I introduce a rule to take care of it. But let's explain this rule, right? I just want to tell you, boom, they're dividing, just subtract. If you ever forget, right, this is what you do. You have a fraction, you have 2 x's on the top, and then you have 3 x's on the bottom, right? So what you're going to do is you're going to cancel an x from the top and an x from the bottom, another x from the top, another x from the bottom. So what you have here is you have a 1 left on top, just because I need to put something there. You have a 1 left, and then you're going to have an x on the bottom. So I'm going to tell you guys in a second, in 2 rules away, how to go from the x to the -1 to the x to the 1. So once again, negative exponents make you angry. So I'll tell you guys how to get there. Before we get there, we got to talk about when you have an exponent raised to another exponent, like you have here, a raised to the b, you're actually just going to multiply in both of them, right? So raising now means multiplication when you have exponents. Let me give you an example, because rules without examples really mean nothing. And professors love to do that. Give you like a 3-hour equation and then go home and do an example, and you have no reference. But here, we're going to talk about, actually, let's go back to blue. So let's say we have x squared, just because I love this example of x squared next to the 3, raised to the 3rd. So all I'm going to do is just multiply x squared times the 3 on top. So it's just going to be x 2 times 3, so x to the 6. So it's going to be a little more annoying showing you guys this example, right? And like x is by itself, but I can still do it. So let's say I have x squared times x squared times x squared, which is the meaning of x squared to the 3rd. I have x squared multiplying times itself 3 times. So I'm going to have x squared times x squared times x squared, right? Which also means x times x for x squared, x times x for x squared, and then x times x for x squared, right? So I have 3 sets of x squareds of just 2 x's multiplying each other. So if I count all my x's, I'm going to have x times x times x times x times x times x. So that's going to be 6 x's in total. If I add them all up, if I use my first rule here of addition when they're multiplying, I'm going to have 2 plus 2 plus 2, right? Which is also x to the 6. And I don't know why I just put a 6 here. This should have been x to the 6. Sorry about that. So anyway we do this, we still get x to the 6, right? Starting with the first rule, going to the second rule we just learned. Now we get to the other rule, which is when we have negative exponents, which, like I said, just make you angry, sad faces. I don't know how to draw an angry face. So here we just have that we're going to go from x to the negative 1 to x to the 1. So how does this happen? Just like that. If you have a negative power, you're just going to put a 1 over that and just flip it and bring it down. So x to the negative 1, just have a little red for emphasis, it's just going to come right down and become positive, right? So same thing, just another quick example, just to tell you guys it's not just with 1. If we have x to the negative 2, it's going to give us just 1 over x to the 2. Now here's something that usually never gets covered but always comes up, right? What if I have a negative on the bottom? Which means that I'm going to have 1 over, scroll up a little, 1 over x to the negative 3, for example. What am I going to do? Well, the rule is the same. If you have a negative power, just change its location from bottom to top, and just change its sign from negative to positive. So you have a negative power. I don't want negatives. I want to make it positive. How do I make it positive? I'm just going to change its location. If it's up, I'm going to bring it down. And in this case, it's on the bottom. So I'm just going to bring it to the top and change its sign. So now it's just going to become x to the 3. So you guys see, whether it's a negative on top or a negative on the bottom, you can still just play with it by just changing its location from top to bottom. So there we go. Now we're going to go over our rules. Now we're going to kind of put them all together and see what we can do with it. So let's try example A1. Alright, so in example A1, I'm going to first go over the rules, and then I'll explain it as if you didn't have rules. And this will probably be the last time I do this, just so you guys get the hang of it. But then we're just going to use our rules because it goes by a little faster, right? So we have 3. It's going to break things down into sections for letter A. So we're going to have 3 and 12, x to the 3 and x to the 2, and y to the 5. And by sections, I just mean by its category, right? So we have a 3 and a 12, which are numbers. So we really just have 3 over 12. Let's put it all together. My bad. So let's have 3 over 12, right? Which, if I cancel that, if I divide both 3 and 12 by 3, I'm going to get 1/4. So my answer is going to be 1 over 4 for the number category, right? And then for the x's, I'm going to have x to the 3 dividing by x to the 2. So that means I'm going to have x to the 3 minus 2, right? So 3 minus 2 because they're dividing, and I'm applying this rule right here, the division rule. And 3 minus 2 is 1, so I'm going to get an x to the 1 on the top. And now I am going to do y to the 5th divided by x to the 2. So this is dividing. I'm going to use the same division rule, and that is going to be the 5 minus 2. So it's going to be y to the 3, right? So if we kind of make this prettier, it's going to be x, y, 3 over 4. That is our final answer in reducing this exponent and simplifying this fraction, right? That's what we're supposed to do here. Just kind of simplify it. So let's say we didn't know these rules, and I tell you guys it's going to be the last time I go over this slow, but just to make sure you guys just understand where these rules come from, because rules are just simple ways of explaining the real thing to you guys, right? So you guys don't have to rediscover it all. It just makes your life faster, and we can move quicker. So let's say I have 3 over 12, right? I'm just going to have 3. I can't break down 3 because it's a prime number. So then x to the 3 is just 3 x's, and then y to the 5th is 5 y's. So we're there. Now we can break down 12 into 3 and 4. it's not as prime factorization, but I'm doing 3 and 4 for a reason. And then I'm going to have x squared and y to the second. So now I'm just going to go ahead and cross things out. So the reason why I broke down 12 into 3 and 4 is because I can cancel this 3 from the top with a 3 on the bottom. I'm going to cancel out 1x from the bottom, 1x from the top, x from the top, x from the bottom. No more x's to cancel, and I move on to the y's. Y from top, y from bottom, y from top, y from bottom. So now I just count. I have one lonely x in the top. So I have x on top. I have 3 y's on the top. So y to the third. And I have one lonely 4 in the bottom. So now the long way and the short way of applying our rules gave us the same answer. Alright? So now we're going to go into multiplying fractions that have a bunch of exponents in them, right? And then eventually in part C we'll do division, which is, this is all no different. It's just little tweaks here and there that we're going to apply. But for letter B, we're going to go straight into our rules and we're going to see. So we use our rules as we go like this, right? So we start off we use our rules from left to right. So let's start off with the multiplication rule, right? So I have two things multiplying. First, I'm going to apply the multiplication rule across these two fractions, right? Just as I move across, instead of try to divide the left and divide the right and then multiply the left and the right, and then I might have to divide again. So let me not do that. Let me just multiply across first and then simplify by dividing, right? So here I have x cubed over 20y squared times z times this other fraction that I have here. So let me go ahead and multiply that, right? So I'm just going to have one big fraction, right? And I'm going to see, okay, I have x cubed and then I have an x to the fifth here. Okay, so that's going to give me x cubed and x to the fifth. That's x3 plus 5. That is x to the 8. Then I run into this lonely 3, nothing else to multiply with. I'm just going to leave it right here, just a 3. And then I have a lonely y squared. So nothing else to multiply except for the x's on the top. Now I'm going to go in the bottom. I look at the 20. It's lonely. I'm just going to bring it right down. And then I'm going to go look at the y squared. And can I multiply the y squared with anything? This 20 is kind of hogging up my space. So y squared is going to be multiplied with y cubed. And that's y squared, y cubed. That's going to give me y to the fifth. It's going to be y to the 2 plus 3. That's y to the fifth. And then I'm going to have a lonely z down here. I'm just going to bring it right down. So now that I'm done applying my multiplication rule, I am going to move on to my division rule, okay, to finally simplify this. So 3 and 20 do not simplify. 3 and 20 do not simplify because 20 breaks down into nothing that divides with 3. So our next step is just going to include a 3 and 20 again because we can't simplify anything. However, we have now x to the 8. Now, there's no x on the bottom to play with this x to the 8, so x to the 8 is just staying as x to the 8. Kind of boring, I know. Now, here we have y to the 2 divided by y to the 5, right? So now we're going to get y to the 2 minus 5, which 2 minus 5 is negative 3, so y to the negative 3. Okay? And then here we just have a lonely z on the bottom, right? We can't even play with it. So let's just kind of leave it on the bottom. It's not playing with anybody. Boring. So now, are we done? No, we're not done. We have this annoying, really annoying negative exponent that is just making you angry. That was supposed to be in blue. Awkward. Angry in the negative exponent. So how do we get rid of the negative exponent? We refer to our negative exponent rule to get rid of it. And in simple terms, when you have a negative exponent, just move its location from top to bottom or from bottom to top, doesn't matter where it is, and just make its exponent positive. So we're going to do that. We're going to rewrite the whole thing. 3 over 20 with a z on the bottom with an x cubed. And now what we're going to do is we're going to rewrite the y to the negative 3 as a y to the positive 3 just now on the bottom. And we're done. We're done with simplifying our exponent. So we can go through all the little rules that we just learned and simplify this stuff out. So now here we have, for C, we have a division. which there's a reason why I included this, right? Because sometimes people forget how to divide fractions, and it comes up all the time when you're simplifying stuff. So we're going to talk about how to divide a fraction and how to divide exponents on a fraction, right? So if you guys remember, when it comes to dividing fractions, we never actually divide fractions. We always just multiply by reciprocal. So let's kind of write that in here. Multiply by recip. I'm just going to write recip because reciprocal is a very long word, and I hope you guys remember recip, reciprocal. Okay? So now what I mean by reciprocal means that I'm just going to switch this from the bottom to the top and then from top to the bottom. So I'm going to rewrite the first. You always keep the first one the same. This one stays the same. So y to the 5th, 14, x squared, y squared times z. Don't let all these variables just scare you. It's really simple if you just go little by little. Times, now this becomes 7, x to the 7, y squared times z, right? Over x cubed. So what that means is that I have now flipped my second fraction. Now I have flipped it, and I'm just going to do the same thing. I'm first going to multiply, and then I'm going to divide, right? I'm going to go across in my rules, and if I need to, I will get rid of any negative exponents. So let's do just that. I'm going to multiply across. So there's y to the 5th. Can this guy mix with anybody? Hey, I found a little buddy here. Y to the 2. So one big fraction. If I have y to the 5th and I have y to the 2, those things are multiplying, so now they're going to add. So y to the 5th and y to the 2 is y to the 5th, 5 plus 2, y to the 7. Now I run into the 7 here. Nothing else to multiply with. I'm going to multiply by 7. And then I'm going to run into this x to the 7. I'm just going to have x to the 7. Nothing to mess with. The z, it's a lonely z. Let's just leave it there. Alright, now let's go to the bottom. 14, can he mix with anybody? Nope. Just leave him there. X squared, does he have a buddy? Yeah, he does. X to the 3rd, so x to the 2nd plus 3, because you have the 2 and the 3 multiplying. So 2 plus 3 is going to be 5. And now we look at the y's, which are lonely. And now we look at the z's, which is lonely. Alright, so now it's time to clean this up and give it its last little touch before we call it done. So, how about, let's start with the numbers, right? So here we have 7 and 14. How does 7 and 14 reduce? We divide them both by 7, so we get a 1 on the top and a 2 on the bottom, right? 7 over 14 is equal to a half, so we're just going to put a 2 on the bottom. And let's not put a 1 on the top because hopefully something else is on there, and we don't want a 1 there because it's just unnecessary. So then we're going to have y to the 7th and y to the 2. So that's going to give me 7 minus 2, so that's y to the 5th. So I'm almost done. I have now x to the 7 and x to the 5th, so that's going to give me x to the 2. And I put the x before the y because I'm very anal when it comes to this stuff, and it's always nice to go alphabetical order, and your professor's going to like it too. So other than that, we're left with the z's, but we have one z on top and one z on the bottom, so that's just 1 minus 1 or 0, so it's just going to cancel. The same thing is just going to cancel, so we have no z's. So now we're completely done. Alright, let me remove myself from there for a second so you guys can see that it's x squared y to the 5th over 2. So that completes our lecture for exponents, and now we're going to go into doing some very, I wouldn't say very difficult, but of higher difficulty examples with exponents so you guys can just get beast at it and finish it up with exponents. So now let's jump into the practice problems, and I'll see you next time.